Hi folks, Bill from Bullseye Power here. We've had a lot of requests. People would like to see what we do here and what we're all about. And if we actually have a balancer. That question came up this week. So I thought today we'd take a little bit of time and address some of those questions that a lot of you had and show you what we actually do here and that we are truly a manufacturer. So we're going to take a walk outside into our assembly and inspection area first. This shelf here is where we keep a small percentage of our housings. There's various different housings, sizes, stainless steel, gated housings, non-gated housings, for many different size turbine wheels. This particular housing here is a 55 AR stainless steel housing. It's a T3 inlet. It's got a 4 or 5 bolt flange. We use these on a lot of the small turbos, 52, 59 millimeter. Sometimes we'll adapt them to a 62 millimeter, depending upon the application. This is a housing that we actually do make in-house. Another one is our stainless steel turbine housings, which we're very proud of. Something I've run in my own car and quite a few of our customers run. These housings are non-divided. They flow very well. They come in many sizes. So the ARs run 10 and 130. We can fit these with an 87, an 83, or a 96 millimeter turbine wheel. Here we have one of our newest style race covers, 83 millimeter, which is a pretty popular turbo. Has the high-rise inlet bell. It's a larger AR than any other cover on the market right now for what was known as the 400 style chassis.
Don't want to talk too much.
Here's our balancer, and this area it's located in is our tear down and inspection area.
Our V-band stainless housings from our Foundry, and these are the 1.3 ARs. Still raw, been through heat treat, but we haven't put them on the machine yet to spin the V-band flanges on both sides, and of course the pocket area for the turbo to sit in. So the next step would be machining and then final inspection, and they'll get cleaned up and ready for sale. Just happen to have a order here for a customer. It's a private label manifold that we do for a customer that is poured out of stainless as well. It's obviously a 4-cylinder manifold for a V-band turbo and maybe a little wastegate here. So won't give you the details on this because it's probably proprietary for our customer.
And Dave, I just happen to have one of the stainless steel housings in a finished condition if you'd like to show the folks that.
Alright, so there's the difference from raw to finished, and it's about, I don't know, about half as heavy as the raw casting, so a lot of material does come off of this unit.
Okay, now we're going to take a walk over just on the other side of the building here to our foundry, one of the foundries where we pour our aluminum castings. And we'll probably have Dave walk us through that on the tour because he knows it much better than I do.
Right this way.
Dave, why don't you go ahead and give everybody a tour of the aluminum foundry?
Sure, not a problem. What you're looking at is the raw material that comes in bars. This is 356 aluminum. Gets melted down in one of these 6 pots that you see around here. 2 at the far end, 2 behind this rack, and 2 over here to the right. And this is where all the aluminum gets poured in a permanent mold process. So what you're seeing right now is a job that they're working on that's some large fans for actually pig farms. This gives you your best surface finish because the mold is the casting, and there's no sand or anything to kind of rough up the surface. If you want, we can take a walk down there to the furnace and take a look and see what's going on. This is a good example of one of the jobs we're also doing. It's like a transmission cover, and the surface finish is very nice, very bright, very clean. You can actually see the lettering. It's not machined in there. That's out of the casting, right out of the mold. Job set up here, the tooling is right there for those fans. We'll squeeze that together, pour the metal in, let it cool, and then use air to separate it and pull it apart.
probably one of the most important areas of the whole place, the snack machines. You gotta have snacks. Hi folks, now we're gonna take a ride up the street to our main foundry where we pour most of our cast iron and stainless steel. This video is gonna speed up. We're gonna do this in quick time. The second building, which is one of 5 buildings that we do reside in and do work out of, is just about a mile up the road. We're going to roll in the shipping gate here. They ship and they receive stuff from all over the world, but this is the easiest way to get in after hours on second shift.
90% of all the material that we pour is actually scrap steel. No sense in using virgin steel. It's a perfect way to recycle, and it's a whole lot cheaper and more environmentally friendly.
And we are an environmentally friendly company. We do care about the environment. Working our way right into what I call the hot pots. How about it, Dave?
Yeah, the first thing you're going to see is a long series of melting pots, or furnaces if you want to call it. They're induction heating, so everything is electric. There's coils in there that heat the metal up to about 2,900 degrees. You can see they've got one active right now. If you look up on the digital readout there, we're at 3,023 degrees right now. We can take a little bit better look up there if you want to come closer.
It looks like they're about to pour right here, Dave.
Yep.
Here we go, perfect timing. My friends, is badass hot molten metal. It doesn't get any better than that.
What you're looking at here is a conveyor system that they use to cycle the bolts through. This is kind of the cooling process, or waiting to put the fire out. These will eventually get pulled down here, and then we'll start breaking the mold out, which is just basically a sand and resin combination that's cooked so that we can actually pour the material into the shape that we're looking for. But once that gets broken out, then the casting's going to get cleaned up in a different department. First I want to show you is the mold department. This is where it really all begins. You'll take your tooling, which is your cast iron shape of your positive impression of your mold, and what we'll do is we'll blow sand and resin into it and cook it to this dark brown, and that gives it that hard shell shape. That way you can pour the metal in there, break the mold out, and start all over again.
And Dave, that has a very smooth surface, doesn't it?
Yeah, our process is a lot different than most. People have heard of shell, maybe. They've maybe heard of sand castings. They may have heard of green sand. Basically, this is the shell process. So instead of just packing in sand and giving you that surface finish of finely ground up sand, we mix it with resin and cook it. So it makes a kind of an eggshell. That's where they get the name shell casting. About a year or two ago, we had a shortage of sand that we used to make our castings, which is that shell mold I was telling you about. It turned out the oil fracking business was taking up all the supply. So instead of the supplier for our sand saying, hey, we can't sell you sand anymore because we can sell it to the oil guys for 3 times the price, they said, well, we're going to teach you how to do it so you can make your own sand. So we added on this whole section of this building here, and up through the rafters there is about a 40-foot building that we sift the sand down and mix moisture to it, and that becomes the sand that we use to cook the resin in. So these are just storage bins and places for the sand to kind of shoot into the mold, make it more automatic. This department here is where we clean up the casting. Now you may not know this, but when you pour a casting, you can't just feed the metal into the part that you want to make. You have to have places to feed the metal on all sides so that the steel doesn't chill off before it fills the whole mold. So what that does is it leaves a lot of scrap material connected to the casting. So these guys are in charge of cutting that off, arcing it off, grinding it, sawing it, whatever it takes to get that gating off, and get the original casting to the customer. This is our stainless steel department, as you saw there, but as you pan across here, each of these cells is people that are working to get those gatings off. These are some big, I would say probably natural gas lines that we pour. And when I was mentioning the gating and the risers and everything to feed that part, this is the extra material here that they're cutting off. So this is the true part and this is the extra material. So that's why there's such a labor-intensive process to get back to the original casting that the customer ordered. I figure while we're walking by here, we'll show you one of our biggest accounts. It's Harley-Davidson, and we make about 6,000 of these every month. And basically, it's the steering mechanism from the front of a Harley motorcycle. So your fork comes through here, handlebars are out here. This is your frame rails, and then we even drill this out so you can lock your steering so they don't steal your bike. Hey, it just so happens we're walking by here and we just poured our new stainless steel version of our T370AR turbine housing. You guys are probably familiar with it. In the past it's been cast iron and it's been a green sand mold, which gives you that kind of rough finish here. Always been shell core in here in the flute so we have good flow, but we've improved the casting by converting it completely over to shell. Nice surface finish. It's now stainless steel instead of cast iron. So the thermal properties are going to improve. It's not going to rust on you. We expect a lot of good things out of this housing.
It's a real nice product and we're real proud of it, aren't we, Dave?
Yeah, this is really a good piece for you. So this is our heat treat department here. This is where all the castings go to get their heat treat process. Every material has a different heat treat process. Some of them are air cooled and some of them are water cooled. And it looks like we had a little leak here. Did some routine maintenance and we have a big flood and Bill's making sure nobody drowns, so he's got his life jacket there signed.
Hi guys, we're in our machine shop now. We're going to go ahead and have Dave give you a tour because I'm not too good at tours in the machine shop. So Dave, why don't you go ahead and show the folks what's going on here.
Well, the first section here you're going to see here is a couple of lathes right here. These are some quick turns. We do compressor covers on there. You'll see a large mill in the middle. Those are basically for bracket jobs and other large milling ops. Along your left side here is going to be some fourth axis mills that we use for exhaust housings and drilling and tapping holes. A couple of unique lathes I want to show you over on this side of the building. These are dual spindle lathes, both of these are. They're auto load and auto handoff. So we can load bearing housings here in these little fixtures. It'll pick up the part, put it in, machine one side, hand it off, machine the other side, all in one step.
See me in there.
We can probably look inside the doors open over there. How you doing? Like I said, this machine is very efficient for loading and machining bearing housings. It'll load this side, do the compressor side, tools will come in, run their ops, hand it off to do the turbine side, all in one shot. This machine can actually run all night and produce over 100 parts in a shift. If you guys remember, we showed you a part over at the Foundry that we were casting out of steel for Harley-Davidson, and it was a steering arm. You can see one loaded right there in that fixture. It's a 4-place fixture, so that machine will run 4 parts at one time. And basically they're just machining those for Harley, and they'll send them out as a finished product. And you'll see them on a motorcycle probably parked on the side of the road one day. What you're looking at now is our mill department. We've got 2 machining centers here. They can load 24 parts per machine, so 48 parts can get loaded and machined without the operator even having to touch the part. This is a Mazak E800. This is one of our favorite machines for machining exhaust housings, especially the larger ones. It's a lathe and a mill all in one. The pallet will turn at up to 1600 RPM, so we can do our lathe features as well as stop and drill and tap and do our mill features. is our latest addition right here. This is actually 4 Mazaks in one, 4 machining centers, which you'll see those 4 pods there. In this front section here, there's 3 loading stations, so the operator can load up to 3 parts at one time. The machine will take that pallet and park it into one of 48 parking spots back there, and then when the machine becomes free, they'll bring another part down, stick it in there, machine it, and it'll run all night by itself as well. Here in our quality control department, this is one of our CMM machines that we use to measure all of our components before we assemble them and put them on turbochargers and send them out the door. This is our latest and greatest machine. This is called a ferro arm. This actually is almost like a 3D scanner. It takes a scan via laser, and you can actually 3D print a part, measure it, and put it into CAD and make adjustments if needed.
That's going to do it for tonight. In closing, this is our shipping department. You can tell that there's a lot of stuff that goes in and out of here all over the world for many different industries, for all the different products that are made here. In closing, we just wanted to point out to the people that did ask for this, and the people that questioned whether or not that there was Chinese cardboard boxes all over our facility, that we actually are in control of our own destiny, and we do make our own products. Thank you very much.